Welcome back for more fun programming. Yesterday we managed to actually draw our texture for the first time, so that's all very exciting. In fact, should we pull that up in case? I mean, it's not like these videos get a lot of views, but if anybody's seeing this one, didn't see the last one, where we are up to is for the first time, I come in here and we go, whoopsie daisy. We run the program. Instead of a hard-coded color, we have a hard-coded texture. Which is a surprisingly large amount of work in Vulkan, but now that's all done, I think we're actually closer than you'd guess to being able to actually write a game, so that's exciting. One thing to say that I think is what we're going to work on next is that black area in the corners of that image are actually meant to be transparent. So we need to go and enable blending. And while it's on my mind, I did also think of another thing that I think... Oh, weird. Why has it done that? I did think of another thing that I wanted to do, which is to enable Z depth comparisons. So that we can draw more than one thing on top of the other without, and get the kind of expected layering, right? So we have one thing move in front of the other, essentially. I've not done it on the other little project I did like this. I think in that one I was just using the order things were being drawn in to control it. I imagine that scales to become a pain, so we're going to try enabling blending, enabling Z depth comparisons, and then I think we sort of stop and have a think just to be sure, but I'm pretty sure at that point we're ready to start actually writing up our game and kind of layout logic and interactivity and all that. So let's get into it. I don't remember really much of anything about how to do blending. I do remember that there's a bit of... Is it even complicated? There's a bit of stuff to work out, right? So maybe I should say, if it's not clear, when I say blending, when we're drawing our transparent area, our problem is the simplest problem, where it's fully transparent, but it could be partially transparent. We need something that tells the, I guess, like the GPU hardware that's doing this maths. Well, I've got a transparent pixel that I've sampled from the texture that I'm meant to be drawing into this destination. That destination has a color. We need to tell it how to combine those two values to make the thing look transparent, right? So when we say it looks transparent, really what we mean is you can't just look at the source image to know what the output should look like. I think our version is going to be actually a really simple version because it's going to be just fully transparent, at least in the first things we do. So I'm hoping we can come up with a really simple tactic for it, but I'm not even really sure where it sits. It must be something in like the graphics pipeline. Is there anything in here? If I say blending, good place to start. So, how do they describe it? Blending combines the incoming source fragments RGB and A values with the destination RGB and A values of each sample stored in the frame buffer. Blending is performed for each color sample covered by the fragment, rather than just once for each fragment. Oh, I've got hiccups. Okay. Source and destination values combined according to the blend operation, quadruplets of source and destination weighting factors determined by the blend factors, and a blend constant to obtain a new set of RGB and A values as described below. It is computed and applied separately to each color attachment used by the subpass with separate controls for each attachment. So does it live on the attachment? Is that what that means? Say in here somewhere? Right, I'll tell you what we'll do is... Oopsie daisy. Not called renderer. There we go. Can we do a search for the word blend? There we go. Said it lived on the pipeline, didn't I? So a pipeline color blend attachment. The pipeline color blend attachment state. Is that what this here is? Pipeline color blend state create info. Interesting. Pipeline blend state is included in the VK pipeline color blend state create info structure during graphics pipeline creation. A bunch of stuff. And a bunch of flags. Pipeline color blend attachment state. What is this then? So the VK pipeline color blend attachment state structure is defined as this. Have that create info in you? No. Am I being daft then? So what's this create info used in? Pipeline blend state is included. The VK pipeline color blend state create info during graphics pipeline production. Pipeline rendering create info. Oh, okay, it's this thing here. And then it refers to that attachment. Got you. Okay, interesting. Okay, so we want to look at this one first. S-type is easy. Flags, did we set any? We haven't got any yet. Logic op, logic enable. Attachment count, attachments, and blend constants. We have the one attachment. So I'm going to cough. In theory, this mic's meant to only pick things up that are really near it, so I don't know how well that died off. I better check that afterwards. Curious to know. Yeah, so I think logic op and logic op enable are probably what we're most interested in, right? Select which logical operation to apply. Attachment count, attachments, and blend constants. Pointed to an array of 4 values used as RGB and A components of the blend constant that are used in blending depending on the blend factor. Okay. Shall we go look at logical operations? That's what we want to know. The application can enable a logical operation between a fragment's color values and the existing value in the frame buffer attachment. This logical operation is applied prior to updating the frame buffer attachment. Logical operations are applied only for signed and unsigned integer and normalized integer frame buffers. Logical operations are not applied to floating point or sRGB format color attachments. That's us then, right? I think that means we can't set this. Because we're using sRGB color attachments, right? Okay. Can we look at the attachments? That, I think, is what I was thinking of, these blend ops. Okay, so I think we can't use a logic op. Actually, we want to be looking up here. I'm sorry, I'm going to sneeze again. Bless me. Have a sip of tea. I wonder if I'm coming down with a cold. It has been grey and miserable. Yeah, I guess it is getting to be late November. What do you expect? Is it still November or is it December? I think it's still November. What was I doing? I'm looking at the state in here. We're going to need to work out values for all of these things. The first thing to do is turn on blend enable. Done. If blending is not enabled, the source fragment colors for that attachment are passed or are modified. Source color blend factor. Select which blend factor is used to determine the source factors. Destination color blend factor. Which blend factor is used to determine the destination factors. Color blend op. Select which blend operation is used to calculate RGB values to write to the color attachment. Okay, what are the values we can have for that then? So if we go look at color blend op, we have add. I mean, add is what I would have guessed you'd do, right? I didn't expect there'd be this many. Min, max, overlay. Alright. Let's just try add. We're going to need an alpha blend op as well. Let's go ahead and just be like, add everything. So the way we get our new values, we just add them. I wonder if there's a description somewhere about how this is actually going to work. Oh, you can dynamically set it. That's interesting. I don't think we need to dynamically set it because we're only going to set it this once. It might be interesting once we've got everything working like we want to do a commit so we can get back and then go through and make everything that can be dynamic and see if it makes things easier to read. We've enabled dynamic rendering, so I think we have access to all these dynamic things, but we've never really taken advantage of any of it. But for now, I'd like to just do the simplest thing that works, and the simplest thing that seems to work for us is we just bang them in at pipeline creation time. So I'm not sure what our blend factor is going to be. We've guessed at a blend op. As we have source and dest. I'm hoping there'll be something to tell us how these things work. What does color right mask do? Bit mask of these components specifying which of RGB and or A are enabled for writing. That's unsurprising. We want to write everything. There's something here about how blending actually works, though. Was that all earlier? Have we skipped past it all? Blend factors. The source and destination color and alpha blending factors are selected from this enum. The semantics of the enum values are described in the table below. Okay. So factor 0 makes it do nothing, right? If we're doing an add. So I'm guessing what we get is that the output triplet is made up by taking this factor for the source and for the destination, timesing each component by it, and then adding them up because we've set the operation to add. So if I have SR coming in and DR coming in, it gets multiplied by, I get SA times SR plus DA times DR. No, wait, sorry, these are alpha. What are we calling this thing? Okay, if we call this value X, then what we would get is, and if we get XS for the source and XD for the destination, then the output red value, I think, will be XS times SR plus XD times DR. And so if it was 0, then actually we just output 0, so we'll get a black image. A blend factor of 1. What does that mean? That they just add. Is that what we want? I'd have thought we want it to be affected by the alpha in some way. Okay, this says, so in this table, the following conventions are used. Tells you the first source color, respectively, for the fragment. Oy, oy, oy. We're not doing two source blending. There's an example in here where they use a blend op and they tell you like what a common thing to do would be. Okay. So if we have add, then R becomes, yeah, what we said. So that all means what I think it means, but I don't think we're going to do an advanced anything. When using one of these operations, we're not using the hue, saturation, luminosity stuff. Ooh, this all seems quite intense. Then logical operations, I don't think we're doing. Okay. So, now we need to do a bit of thinking. How do we want our values to behave? I'm not sure how you would expect transparencies to interact, other than to say, they're adding two transparent things, they should stay transparent. I got a thing I can like scribble notes in. I normally do this on pen and paper, but that seems pretty bad for a video, doesn't it? So we're going to have to make a blend factor. Just put to-dos by the ones we need to think about. Have a destination color blend factor. Maybe even actually we just do this and we see how it comes out. And we can play with it a little bit. Oops, source, alpha blend factor. Destination, alpha blend factor. So this probably won't work, right? Because, ooh, it sort of kind of worked. So you can see we've made the outside transparent. Right, it's no longer drawing a square, we are drawing a circle, basically. We just happen to also made everything else look wrong. So I guess that's promising. I have a drawing thing. I think I installed external. It's in mind. Where do I get rid of you? Yeah. In fact, I might pause recording and see. I think I've got a drawing pad thing. I might be able to write this more neatly with that. So I will be back in 1 second. See if I can find it. Where's the pause button? There we go. I found it. Alright, let's see if this is any better than writing with my pen. Oh, my handwriting is not great, is it? But I'm not sure. Snapping straight lines either. That feels more natural there. Okay, it erases on whole lines. That's useful. I'm going to cough. Okay, let's go with that. I'm not sure actually. Does the line need to be a bit fatter? Right, that's a bit tiny. That's something I can change up here. Standard. There must be a way to change how that looks. View. Toolbars. Sidebar. Okay. Standard. How do you thick? That can't be. Surely not. Now. Just scroll in a bit. Like that. That work? That looks readable at least. Cool. We will experiment with that. Okay, so what have we got? We've got source coming in. So I think this will be the value from our sample texture. We have a destination. So let's call that R. No. Call that, yeah, R, S, G, S, B, S, and A, S. You've then got RD, GD, BD, AD. Remember, this is a color, and this tells us how transparent that color is meant to be. Right? So, if that value is 0, it's opaque, and if this value is 1, it's fully see-through. We're going to define a factor, which we're going to call It's F for factor, S for source. No, it's gonna have something else to be per component as well, right? Let's call it S and D. So we can have SR, SG, SB, SA. Here we're gonna have not S, sorry, D, R, DG, DB, and DA. Right, and we need to decide on what we do to get our output. So what seems sensible? I assume the values are going to just kind of clip rather than overflowing. So if we have maximum red and maximum red, I'm assuming we don't have to worry about taking a max, and we just add them and it'll give us maximum red, basically. So I would guess that what we want to do, because we're a bit zoomed in now, let's zoom it out a bit so we can see a bit more, is, okay, so R out, I would think we want to do what value do we want to get out, and then we can work out what S and D need to be, right? So if that ends up just being, what? So if they were completely opaque, we would want to just do RS plus RD, right? The more red, no, it's not that simple, right? Because if the source is completely opaque, we want to just get source, don't we? So what does that mean? Is if source is completely opaque, so if A is 0, we want the full value of that. 1 minus AS. Alright, so if A is 0, the source that we're sampling is completely opaque. The end value we get is just the value from the source, right? And I guess we then want to say plus RD, also AS, right? So it's like we're doing a linear interpolation between the two values. That sounds like what we want, doesn't it? Which was probably a color blend op and not a factor issue. And then the other colors will be the same. Then need to just work out what we want to do with our A out. What do we do with A out? We just add A in and A dest, right? Not S, A source and A destination. So if they're both transparent, we get transparent. If one's not transparent, no, okay, that doesn't make sense, does it? So if either of them is opaque, the output needs to be opaque. So maybe this needs to be a minimum of a, what have I actually called a source and a dest. So my output is opaque if either of them's opaque, and it's transparent if they're both transparent. What that would do. Right. Is there a color blend op that sounds like that? Jump to see what they are. Extensions. Source color blend. We need to think about this op business a bit more. What have we got? We've got our different factors. You can get minus a blend factor 1 minus source alpha, blend factor 1 minus dest alpha. We care about dest alpha when we pick it. I'm not all the way sure. That's what I've written, right? We're going to multiply the source values by the amount of source alpha. These should then be source alpha. Alright, what are the values we can pick in here then? Minimum, source alpha saturate. Different op here. It's a min. What does that give us? That does not look right. Okay. Have we just got these back to front? So max if there's a min. That's not changing anything. Stick with our guns. Assume that means min. Keep them as 1 and 1. What if I just turn these around? Your source alpha and your 1 minus source alpha. That looks more promising. Have I got the value of alpha wrong in my head? Is alpha... An easy way to look that up. Vulcan alpha meaning? Alpha channel used to make objects appear, blah blah blah. If the AI has the answer. Alpha has transparency. 0 means fully transparent. I was doing that the other way around, wasn't I? Yeah, that didn't make sense. Should this then be max, not min? If I do that. In our case... Oh, what does it do in our case? I'm not sure what it does in our case. So 0 is fully transparent. Let me just note of that. Future me is going to care about that. Note alpha 0 implies fully transparent. Right. So we thought it needs to be a min. We had it backwards. What we're saying is it should only be transparent if they're both transparent. If either is opaque, we should take the more opaque. So yeah, it should be a max. And then there is no color blend between them. Yeah, I think that makes sense. Grab all this. Cool. So I think we've done color blending. That was not as hard as I thought it would be. It works, it all moves around and resizes. Beautiful. Right, I'll be honest, I'd kind of planned in my head that that was going to be today's entire video. But, I mean, we flew through that. Do a commit. Enable blending to allow for transparency in textures. Textures. Push that upstream. I'll tell you what though, that does feel like a natural ending point for a video. So I do think we're going to leave it there. And we'll pick up the depth buffering stuff in the next one. So this might be the first video where I've done something faster than I thought I was going to. Or if you told me at the outset it was going to take us about 18 videos to draw a smiley face, I would have laughed at you. But maybe this is it. I think I said on one of the streams that once we draw the triangle, it was all going to get easy and go downhill. Maybe we actually are easy and going downhill now. We'll see. But yeah, so on the next video, we'll get into the Z depth comparison stuff, which is all going to be new to me. So we probably grind to a halt again, but it will be fun. I will catch you next time.